Hey guys, Assalamu alaikum. We're starting a new lesson, and for today we're doing yet another topic from Algebra, the questions of which will be revolving around distance, time, and speed. That's for the quantitative section. For the verbal section, we are going to be continuing with our practice on sentence completion. Let's start with the quantitative section. We've got a total of 8 questions for each side. Again, I would like to remind you to make quality your priority and not the quantity. So we've only got 8 questions, but what you're going to be doing is going through them, trying to attempt them yourself before I do, and then thinking, if you got it wrong, excellent. If you got it right, excellent. If you got it wrong, I want you to think about why did I get it wrong? Did I not know it? Was there a problem with the concept? Or was it a careless mistake? Or for example, follow me with the first 2 questions, and then the third one, you're like, okay, now I got the hang of it, so you move on. So I hope you got the idea. Quality over quantity. Let's start with the first question. Now there's this person that crosses a 600-meter long street in 5 minutes. So we've got, by the way, I hope everyone knows the formula for the speed distance time. The formula for the speed distance time, we know it. Speed equals distance over time. Hopefully you just did this recently, either math or physics, it comes up in both the subjects. Speed is distance over time. So continuing, now I do know that I've got 600 meters, that's my distance. And the time is 5 minutes. And what's needed is speed, but the speed's needed in kilometers and hours. So I've got 600 meters would be equivalent to, if I want to change meters to kilometers, what I do is divide by 1,000. So I get 600 over 1,000 kilometers. And for minutes, I have 5 minutes. If I want to change that to hours, because we're working with hours, what would I do? It's 5 minutes. It's a very small fraction of an hour, if I'm right. So that would be 5 over 60. 5 over 60 of an hour. So I've got the distance and the time. What they're interested in is the speed. Recalling the formula, speed equals distance over time. So I've got the distance, which is 600 over 1,000. Because I've got a fraction already, I wouldn't write this over sign. I would rewrite it as division. I'd like to rewrite it as division. So I would say divided by time, which is 5 over 60. I just need to work that out. So the speed is 600 over 1,000 times 60 over 5. Now I know that's the table of 12. 5 times 1, 5 times 12. The 0 goes with the 0, the 0 goes with the 0. So I'm left with 6 times 12 over 10. 6 times 12 is 72, divided by 10. How do I write 72 divided by 10? I know the decimal over here, it moves back 1 unit, so I end up getting 7.2. And that's it. It looks a bit long with the explanation, but if you know the concept and you're okay with it, it would only take you 2 steps to work it out. Let's go on to the next question. An aeroplane covers a certain distance at the speed of 240 kilometers per hour. That's kilometers per hour. So the speed is 240 kilometers per hour. In 5 hours, so we've got the time as well. The time is 5 hours. To cover the same distance, now they haven't given us the distance, but I would say distance equals x. I don't know what it is. To cover the exact same distance, let's say here, in 1 2/3 of an hour, can I rewrite that as 1 2/3 of an hour? Can I make it into a fraction? 3 times 1, 3, plus 2, that's a 5 over 3. So the time is 5 over 3 of an hour. And they're saying, what's the speed that it should travel on? What's the speed that it should travel on? Now, if I do it the theoretical way, what I would do is apply the speed distance formula over here. Apply the speed distance formula over here, get the distance. Once I get the distance, what I would then do is, actually, shall I work it out? Speed equals distance over time, right? Speed equals distance over time. So I'll take t to the other side so that I get d equals s times t. I know my speed, according to the first scenario, is 240, and the time is 5. 5 times 240. I don't know how much that is, I'll just keep it the way it is, which is the exact same distance that they covered in the second situation, which is 240 times 5. Now, I can again apply the speed distance formula. I can go speed equals distance over time, and apply it on the second situation here. Distance I know is 240 times 5 over, I know the time is, actually let me rewrite it, because whenever fractions come up in the denominators, I prefer writing it as like this, divided by 5 over 3. So that's the time, 5 over 3. Now what I would do is 240 times 5, switch the fraction, multiplication, that becomes 3 over 5. 5 goes off with the 5, and I'm left with 240 times 3. 240 times 3, again, I don't know the table of 24. What I could do is, I would like to split that into times 10. That's this here. And 24, I know I can split it into 2 times 12. 2 times 12, and I've got the times 3. 2 times 3 is a 6 times. 2 times 3 is a 6, I'm left with 12, and 10, that's, let's just say this. Then 6 times 12 is a 72, times 10, that's 720. 720, this one over here. So I know that's extremely long, but what I would like to do is, I know that's extremely long. I would like to highlight, because I wanted to explain to you the theoretical way of going by it. Now, I would also like to tell you one more thing. You're going to hate me for this. But here, we can do it in a much simpler fashion. I'll do it here. I'm just going to use this piece of information. We can do it in a much simpler fashion. I know that speed and time are inversely proportional to each other, right? I'm going to use ratios over here. So I know I have a 240 for the speed. That's in 5 hours. And I want to find out the speed in 5 over 3 of an hour. I'm using this information here. I'm explaining to you a second way of doing this, which is fairly easier, much easier. So I'm using ratios. In ratio, am I allowed to, okay, the more the speed, the lesser the time. If I'm traveling to a place at a very slow speed, it would take me more time. If I go faster at a faster speed, it would take me less time. So that's the idea. They are inversely proportional to each other. Inversely proportional to each other. Which means, do I cross multiply or straight multiply? When it's directly proportional, I cross multiply, right? When it's inversely proportional, like it is in this particular case, I straight multiply, remember? From the topic in ratio. So I would say 240 times 5 is equal to 5 over 3 times x. Yeah? 240 times 5 is 5 over 3 times x. And that's it. I'll just work it out. I take 3 to, actually, when I want to take a fraction to the other side, I find it easiest to multiply by the reciprocal on both sides. So the 5 goes off with the 5, and the 3 goes off with the 3. I'm left with an x, and the 5 goes off with the 5. 3 times 24, again, I would do the exact same thing in my head. I would break it down into 12 times 2 times 10. So I can work with it. It's easier for me to work with it because I know that's 3 and 2 is a 6, that's a 12, and that's a 10. 7, 20. Anyhow, whichever is easy for you. Some students, no matter how much I convince them, they want to do this. So no problem. I mean, whichever is easier for you. I personally find mental math a lot easier. So we're going to use the exact same concept of ratio in the upcoming questions. We wouldn't go through this entire long situation. We're just going to apply ratios now that we know them. Next question number 3. If a person walks 14 kilometers per hour instead of 10 kilometers per hour, so there are two situations. In one of them, the person's walking at 14 kilometers per hour. At the other situation, they're walking at 10 kilometers per hour. He would have walked 20 kilometers more. Okay, so over here, we don't know how much he's walking over here, but over here he's walking 20 kilometers more. What's the actual distance traveled by him? What's the actual distance traveled by him? They want you to find out the value of x. Now, can I write them in ratio again? Can I say, okay, over here we're comparing speed with distance. The more the speed, what happens to the distance? The more distance you cover, the lesser the speed, the lesser distance you cover. So they are directly proportional. They are directly proportional, which means one increases, the other increases as well. So I've got 14 kilometers per hour, the speed. In this speed, he manages to cover this distance, and at this speed, he manages to cover this distance. Because they are directly proportional, I would cross multiply. That would give me 14 times x equals 10 times x plus 20. All you need to do is work that out. That's 14x equals 10x plus 20 times 10, that's 200. Let's take the 10x to the other side. So I've got 14x take away 10x, which is 4x, equals 200. 4 times what gives you 200? 4 times what gives you 200? 50? 20 is 5, that's a 1, so I'm left with a 50. X equals 50. That's the answer. So that's the answer to question number 3. Let's move on to question number 4. Excluding stoppages, the speed of a bus is 54 kilometers per hour. Okay, so the speed of the bus is 54 kilometers per hour. If there are no stoppages, so it's moving continuously. Whereas if it does stop, sometimes, for example, stopped here, stopped here, stopped here, so we don't know how many stoppages, the speed is 45 kilometers per hour. For how many minutes does the bus stop per hour? So they're saying, first of all, how much is the distance that they cover in an hour? The speed is given in 1 hour. It's 54 kilometers per hour. That means the distance that you're covering per hour is 54, and the distance that you're covering over here per hour is 45. So for how many minutes does the bus stop per hour? So would I be right to say the difference between them, 54 and 45, is a 9? So that's 9 kilometers. 9 kilometers. The bus stops for 9 kilometers out of the total 54. The bus stops for 9 out of the total 54. And because they're saying they want it per hour, remember we are dealing with we've got everything in hour, but they want it in minutes. So this is the amount, but because they want it in minutes, all I'll do is I'll multiply by 60 to give them the answer in minutes. To give them the answers, I'll multiply by 60. Now all I need to do is simplify. 6 times 10, 60. 6 times 9, 54. 9 times 1, 9. 9 times 1, 9. That leaves me with a 10. So that's for 10 minutes. The bus stops for 10 minutes every hour. Next question, question number 5. 2 trains starting at the same time from 2 stations 200 kilometers apart are going in opposite directions. So you've got station A and you've got station B. I'm just naming them. 2 trains starting at the same time from 200 kilometers apart. And they're going in opposite direction. One of them's going here, the other one's going over there. They cross each other at a distance of 110. So let's say somewhere here. That distance would then be 110. What's the leftover distance? 110 take away from 200 will give you a 90 from one station. What's the ratio of their speed? What's the ratio of their speed? Now this is a fairly easy question because one of them covered 110 in whatever amount, we don't know how much, let's say x, and the other one covered 90 in, let's say, the same amount of time. So 90 kilometers in x hours, let's say, and 100 kilometers in x hours. Do you see that it's like a multiple of 90? I'm going to separate it over here. I'm going to separate it for you to see easily that it's like, it's 99, 90. It's the same thing as saying 90 times something and 110 times something. That's the ratio. So the ratio is 90 times something to 110 times something, because one of them covered 90 kilometers, the other one person covered 110 kilometers. Now, if I simplify that, first of all, I would divide by that saying something. I don't know what it is, but just for explanation's sake, these things cancel out, then I have a 90 to 110 left. I divide by a 10. 0, 0, 0, 0 cancel out, I'm left with a 9 to 11. Can I simplify it anymore? No, I don't think so. That's the answer. 9 to 11, I got 9 to 11. Over here, the answer states 11 to 9. It doesn't really matter because they haven't given us two options, 11 to 9, 9 to 11, nor would they, because they did not specify which station to take first. So 11 to 9, 9 to 11, maybe I worked it out the other way around. You could have drawn it like 110 here and 90 here. But then again, because they didn't mention it, doesn't matter. Next question, question number 6. A train covers a distance in 50 minutes. A train covers a distance in 50 minutes. If it runs at the speed of 48 kilometers per hour on an average, okay, so the distance that it's covering is 50 minutes. It runs at the speed of 48, so the speed that you've got is 48 kilometers per hour on an average. The speed at which the train must run to reduce the time of the journey to 40 minutes will be. So now they want the journey to be only 40 minutes. What needs to change? The time isn't changing. By the way, if you pay attention, time is constant. Time is constant. When one of the things is constant, that's when I can apply ratio. The speed is what they want me to find out. What I would do, I know distance and speed are both directly proportional to each other, so I would say 50 minutes, 48 kilometers per hour, 40 minutes, x kilometers per hour. Do I cross multiply? Yes, I cross multiply, right? Because it's directly proportional, I cross multiply, I'll say, okay, 50x equals 40 times 48. Divide both sides by 50, so I only have an x left over. 0 goes with the 0. Actually, no, then the workout will become a bit difficult for me. What I could do is, to make things easy, I want to simplify. Let's simplify by 5. Divided by 5, that's a 10, and that's an 8. Okay, we need to start over this question again, because I misunderstood time to be distance. Okay, let's take a look at it again. Now they're saying a train covers a distance in 50 minutes, that's time. If it runs at the speed of 48 kilometers per hour, that's speed. That's situation 1. The speed at which the train must run to reduce the time to 40 minutes. So that's the second situation. They want it reduced to 40 minutes. What will the speed be? What will the speed be? Because the situation is they're not changing the distance. It's the distance that's constant, which means I can apply the ratio, and I know speed and time are inversely proportional to each other. Speed increases, time decreases, so forth. Okay, so if they're inversely proportional to each other, what do I do? Cross multiply, straight multiply. I straight multiply. So I've written down the values and I straight multiply. That would give me 50 times 48 equals 40 times x. So I divide both sides by 40 to have just an x on the right hand side, whereas on the left hand side, the 0 goes with the 0. 4 times 1, 4. 4 times 12. 48. 12 times 5 is a 60. That's my answer. Okay, straightforward again. Other than that mess in the beginning, it's a straightforward question. Next question, question number 7. A train covers a distance in 100 minutes if it runs at the speed of 48 kilometers per hour on average. So, oh, it's a very similar question, just some values changed. Try it, please. So the distance in 100 minutes, so it's 100 minutes time. The speed is 48. 100 minutes, the speed is 48 kilometers per hour. The speed at which the train must run for the time of the journey to be 40 minutes. Exactly the same thing. You straight multiply because it's inversely proportional. More the time, less the speed, speed, more the time. 100 times 48 is 40 times x. Divided by 40, divided by 40. So I only have an x on the right hand side. On the left hand side, exactly the same thing. 0 goes with 0. 4 times 1, 4. 4 times 12, 48. That's 120. Answer. Do you see how simple the workout is getting? It's actually because it's that simple. Initially, I had to do so much of workout to be able to get the message across of how to work with them. But they are very easy questions. And basically, these questions are ratio-related questions. That's why they come up in aptitude tests. Last question, question number 8. Two stations A and B are 100 kilometers apart on a straight line. So there's a straight line. There are two stations A and station B. That is 110 kilometers apart. One train starts from A at 7 a.m., okay, at 7 a.m. and travels towards B at 20 kilometers per hour. Another train starts from B at 8 a.m. and towards A at 25 kilometers per hour. At what time will they meet? So definitely they would meet because one's coming this direction, the other's going this direction. They would meet, but at what time? I find it the easiest to take help from the MCQs, the options, at 9 p.m. Let me check what's happening at 9 a.m. 9 a.m. So A is over here, there's B there. The total distance is 110. From 7 to 8 a.m. Actually because we're talking about 9 a.m., right? Let's work from the right hand side. At 9 a.m., because this particular train is traveling at 25 kilometers per hour in 1 hour to 9 a.m., it would have traveled 25 kilometers, right? 25 kilometers. It would have traveled 25 kilometers in 1 hour. Whereas what would have happened on the left hand side, on station A, from 7 a.m. to 8 a.m., it would have traveled at 20, right? Because it's traveling at 20 kilometers per hour. And then from 8 a.m. to 9 a.m., it would have traveled another 20. That's a total of 40. So it traveled 40 kilometers at 9 p.m. That doesn't look like they're meeting up. Let's go another hour. Let's try to look at 10 p.m. 10 p.m. Let's see what's happening at 10 p.m. At 10 p.m., that's one more hour. That means a plus 20 here because it's traveling at 20 kilometers per hour, and a plus 25 here because it's traveling at 25 kilometers per hour. So that would be a 40, and another 20. That's a 60. So it's 60 kilometers, 40 from here, and another 20. 60 kilometers, and at B, it would have been, it was already at 25 kilometers. It travels another 25 kilometers. 25 and 25. Let me write it here. 25 plus 25. This 25 plus 25 would have been 50. That's 110, isn't it? That's a total of 110. So they actually meet at this particular point where B has traveled 50 kilometers and A has traveled 60 kilometers. Again, because I'm explaining it to you, it's taking a bit longer. If you try and do it in your head, it would be a bit quicker. We can do this question using the formula, distance time speed formula, but I just find this way easier. That's it. Let's move on to the second section of our class for today. Okay, sentence completion. Again, we're going to be doing a total number of 8 questions on sentence completion. What we want to do is, again, focus on quality rather than quantity. If you're getting them right, brilliant. If you're not, why are you not getting them right? Did you not know the concept, or was it a careless mistake? Let's start. The dash successfully repelled every dash on the city. The defenders successfully repelled every comment on the city. That makes no sense whatsoever. The citizens successfully repelled every onslaught on the city. Doesn't make much sense either. The thieves successfully repelled every robbery. That is not something you repel. The judge successfully repelled every criticism on the city. That is the only one that's closest because it's making a bit of sense compared to the others. Let's take a look at question number 2. His presentation was so lengthy and dash, so it's something to do with lengthy and dash, that it was difficult for us to find out any real dash in it. It was so lengthy and dash that it was difficult for us to find out any real dash in it. Verbose is the first word, and spot on because that means it's a lot of words. So you're talking about a lot of words that are not necessary. His presentation was so lengthy and verbose that it was difficult for us to find out the real content in it. Actually, it makes a lot of sense. It was difficult for us to find. His presentation was so lengthy and tedious that it was difficult to. Tedious is something boring, but you can't apply tedious to presentation. And real skill in it. The presentation doesn't necessarily need skills. Simple coverage. This is the only one that's making sense. Question number 2. The answer is A. Question number 3. The people of Europe came to India, dash for riches, followed by the desire to rule. So they came for something and then that became into something else. That means initially they came for one particular thing. The people of Europe came to India basically for riches, maybe, followed quickly by the desire to rule. The people of Europe came to India fundamentally for riches. The people of Europe came to India primarily for riches. The people of Europe came to India seeming for riches. This is the only one that suits the best. Let's go with C. Next question, question number 4. The village headman was unlettered, but he was no fool. He could see through the dash of the businessman's proposition and promptly dash him down. So it has to be something opposite to he was no fool. Not really, because they said he could see through the dash of the businessman's proposition. So he could see through something of the businessman. Deception, maybe. It could be deception. But deception is through action. When you say deception, that means like you're deceiving through action, whereas the businessman is not taking much action here. And promptly forced him down. Force doesn't look very appropriate either. Next, you've got the next question we've got is naivety, which is exactly the opposite of what we're looking for. We're looking for something which is smart or not smart, clever, or a bit evil. And promptly turn him down. Actually, turn looks like more of a suitable fill-in for this blank. He could see through the potential of the businessman, not really looking for something. So the village headman was unlettered, but he was no fool. He could see through the sophistry of the businessman's proposition and promptly turn him down. This looks like the most appropriate. D. Next question, number 5. If a junior executive neglects his professional development and dash education, he can easily and quickly become obsolete in the world changing at dash rates. If a junior, let's try and fill it in. If a junior executive neglects his professional development and higher education, he can easily and quickly become very obsolete in the world changing at vulnerable rates. Actually, it's not so vulnerable because it's kind of steady. It's not, I wouldn't go with that. B. If a junior executive neglects his professional development and management education, he can easily and quickly become obsolete in the world changing at supreme rates. No. Let's try the other one. If a junior executive neglects his professional development and better education, he can easily and quickly become obsolete in the world changing at supreme rate. If a junior executive neglects his professional development and continuing education, he can easily and quickly become obsolete in the world changing at dizzying rates. So dizzying makes quite a lot of sense because dizzying is something that makes you feel unsteady and confused. So like at very rapid rates, basically that was the word we were looking for. And continuing education. So let's go with D. Next question, number 6. The dash terrorist was finally dashed by the police. The famous terrorist was finally dashed by the police. We don't use, it's not a celebrity, we don't use words like famous usually. Notorious is something we can use for the terrorist. The notorious terrorist was finally nabbed by the police. The crafty terrorist was finally admonished by the police. Admonished is very light because if they're finally doing something, we don't go with admonished. A renowned terrorist was finally caught by the police. Again, not a word that we would use, although they mean the same thing, but notorious is a better filler for the first blank. Next question. Question number 7. The quality of dash between individuals and the organization for which they work can be dashed to the benefit of both parties. The quality of dash between individuals and the organization. The quality of life between individuals and the organizations for which they work can be, no, life doesn't look okay. The quality of interactions between individuals and organizations for which they work can be dashed to benefit both parties, can be improved to benefit both parties. Looks okay. The quality of service between individuals and the organizations for which they work can be evaluated to benefit both parties, isn't fitting quite a lot. The quality of sophistication between individuals and organizations for which they work can be developed to, this looks perfect. B. Okay, next question. Question number 8. While the world was dashed to the happenings in Washington and New York, America's political class was dashed by the attacks. So they're talking about the attacks. While the world was watching to the happenings, isn't fitting in, watching to the happenings. While the world was alert to the happenings in Washington and New York, America's political class was concerned by the attacks. Isn't quite fitting in again, concerned by the attacks. While the world was averse to the happenings in New York, to Washington and New York, America's political class was excited by the attacks. While the world was glued to the happenings in Washington and New York, America's political class was devastated by the attacks. Looks quite okay, so that is the answer to the last question. That's it, we are done for today, but I would like to remind you to keep up with the timetables and the vocab. Keep up with them. There might be words, you can fill in the vocab journal from today's lesson and keep up with the timetable as well. I'll catch you tomorrow. Till then, keep shining.